Imagine this, the universe, everything we've ever known, every star, every galaxy, every flicker of light across the cosmic void is expanding. But expanding into what? If the universe is all there is, how can it grow into anything else? What if it's not stretching into emptiness, but into something so strange, so mind-bending, that it defies every rule we've ever written about reality? A jaw-dropping simulation, crunched through the colossal power of Microsoft Azure's cloud network, just uncovered something that's sending shockwaves through the world of cosmology. The results? They're rewriting what we thought we knew about the edges of existence itself. Buckle up, because this is going to be a wild, emotional ride into the unknown. A discovery that might just change how you see the universe forever. Let's set the stage. For centuries, we've gazed at the stars, mapping their dance across the sky, trying to crack the code of the cosmos. We've built telescopes that peer billions of light years away, detectors that catch whispers of ancient gravity waves, and particle accelerators that smash atoms to reveal the building blocks of reality. But there's always been one question nagging at us, one puzzle we couldn't solve. Why is the universe speeding up? Galaxies aren't just drifting apart. They're racing away from each other, faster and faster, pushed by a mysterious force we call dark energy. Nobody knows what it is. Nobody knows why it's happening. All we know is that the universe is ballooning outward, and we've assumed it's expanding into nothing, just an infinite void. But what if we were wrong? What if the universe is pushing against something? Something real, something alive, with its own rules, its own structure. This is where the simulation comes in. A team of brilliant minds, armed with the most advanced tools in astrophysics, decided to probe the edges of space-time itself. They weren't just studying stars or black holes. They were trying to model the boundary of the universe. Picture it. A digital cosmos, built from the ground up, designed to mimic the furthest reaches of reality. This wasn't a simple computer game. It was a quantum masterpiece, weaving together data from space telescopes, gravity wave observatories, and particle experiments. The goal? To understand cosmic acceleration, to figure out why the universe is speeding up, and whether it'll keep going forever, or someday stop, or even collapse. But to pull this off, they needed raw power, the kind of computational muscle no single lab could provide. Enter Microsoft Azure, a cloud network capable of chewing through petabytes of data, enough to fill millions of hard drives, and spitting out answers to questions we barely knew how to ask. Here's where things get electrifying. As the simulation ran, churning through trillions of calculations, something bizarre started to show up. At the outer edges of the model, where the universe should have been stretching freely into nothingness, there was resistance. Virtual particles, the tiny building blocks of the simulation, weren't behaving as expected. They were slowing down like they were brushing up against an invisible wall. This wasn't some glitch or coding error. It was consistent, repeatable, and completely unexplained by any known law of physics. The data screamed one thing loud and clear. The universe isn't expanding into nothing. It's expanding into something. Something with its own properties, its own texture, its own presence. The numbers hinted at a higher dimensional field, a kind of cosmic friction that's interfering with the universe's growth. It's as if reality itself is rubbing shoulders with another realm, creating ripples that bounce back and mess with the fabric of space-time. Feel that chill running down your spine? That's the weight of what this means. For decades, We've tossed around wild ideas about extra dimensions, spaces beyond the three we move through every day, plus time. Most scientists shrugged them off as fun to think about, but impossible to prove. Too speculative, they said. Too out there. But now, this simulation is flashing warning signs that those ideas might not be so crazy after all. The resistance wasn't random. It varied, depending on the direction of expansion, like the universe was pressing against a surface with peaks and valleys, not a smooth void. And it wasn't just a static barrier. The patterns showed waves, like ripples in a pond, as if the universe's expansion was stirring up whatever lies beyond and sending echoes back. This isn't just science, it's a cosmic detective story, and we're finally picking up clues about a mystery bigger than anything we've ever faced. Let's dive deeper, because this gets even wilder. The simulation wasn't just a one-off experiment. The team ran it hundreds of times, tweaking every variable they could think of. They swapped algorithms, adjusted the physics, even rewrote parts of the code to rule out mistakes. But the anomaly kept showing up, stubborn and undeniable. At the edges of the model, space-time acted like it was hitting a shoreline, with currents and eddies that didn't match anything in our textbooks. The math pointed to something called bulk resistance, a term that's been floating around in the fringes of theoretical physics. It's the kind of thing you'd expect if our universe isn't floating alone in a void, but is instead embedded in a higher dimensional space, a vast, unimaginable bulk that surrounds us, invisible but real. Picture our universe as a bubble, drifting in a sea far bigger than itself. We're inside the bubble, looking out, thinking the walls of our reality are all there is. But what if those walls are pressing against other bubbles, other universes, each with their own laws of physics? The simulation suggests exactly that. The resistance patterns weren't uniform. They showed a directional bias. In some parts of the model, the universe seemed to slow down, while in others, it sped up, as if something outside was pulling or pushing unevenly. This wasn't chaos. It was structure. Whatever's out there isn't just a featureless void. It has shape, maybe even purpose. The team described it as a cosmic flow, a current that's guiding the universe's expansion in ways we can't explain from the inside. Now let's take a moment to let that sink in. If this is true, it means our universe isn't alone. It's not an isolated snow globe spinning in emptiness. It's part of a cosmic ecosystem, a network of realities brushing up against each other, influencing each other's paths. The simulation even hinted at something called brain friction, the idea that our universe, a four-dimensional brain, short for membrane, is sliding past another brain in a higher dimensional space. That friction could explain why we see weird gravitational effects in our cosmos, things we've blamed on dark matter or dark energy. What if some of that dark stuff isn't in our universe at all? What if it's the shadow of another reality? It's gravity leaking across the divide, tugging at our stars and galaxies. This is where your heart might start racing, because the implications are staggering. If our universe is bumping into a neighbor, it changes everything we thought we knew about the Big Bang, the birth of existence itself. Maybe it wasn't the start of everything, just the moment our bubble formed, sparked by a collision with another brain or a split from a parent universe. The end of our universe, that far-off heat death we've dreaded, where everything fades to cold emptiness. It might not be an end at all. It could be a transition, a merging with another reality, or a rebirth into something entirely new. The universe isn't just a one-act play, it's a saga, unfolding across dimensions we're only now beginning to glimpse. But wait, because this story takes an even stranger turn. As the simulation dug deeper, it hit something that made everyone stop and stare. Beyond a certain point, roughly 16.8 billion light-years from any observer in the model, the math started to break down. Not because the computers couldn't handle it, but because the physics stopped making sense. The equations that govern space-time, gravity, and quantum fields, they just quit. It was like the simulation had reached the edge of a map, a boundary where reality itself refuses to go further. The team thought it was a bug at first. They poured more computing power into it, rewrote the code, checked every line. But no matter what they did, the boundary held firm. Expansion slowed as it approached this limit, never quite crossing it. Like a runner forever inching toward a finish line they'll never reach. What does that mean? One possibility is that we've found the edge of our universe. Not just a horizon we can't see past, but a literal wall. A cosmic firewall, some call it. A barrier that separates our reality from whatever lies beyond. Is it a natural limit, like the surface of a balloon? Or, brace yourself, is it something designed? The patterns in the simulation showed eerie similarities to error correction codes, the kind we use in quantum computers to keep systems stable. At the edges, the math simplified, like reality was being optimized to save processing power. It's the kind of thing you'd expect if the universe were, well, a simulation. Not a fake world, but a system with rules that look suspiciously like code, running on a framework we can't yet understand. Let that hit you for a second. What if the universe isn't just expanding into another dimension? What if it's expanding into the limits of a program? The constants of nature, the speed of light, the strength of gravity, the smallest units of space and time. Could they be the resolution settings of a cosmic computer? The reason quantum particles act weird when we observe them, collapsing into one state or another, could that be the system rendering reality only when it's needed? This isn't about some alien teenager playing a video game with our lives. It's about reality itself, being built on information, a mathematical structure so deep that what we call physics is just the surface of something far more profound. Now let's pull back and feel the weight of this discovery. If the universe is part of a higher dimensional bulk, or the edge of a cosmic simulation, it doesn't make our world any less real. The stars still burn, gravity still pulls, love, fear, hope. They're still the pulse of our lives. But it means our story is bigger, richer, more interconnected than we ever imagined. Every galaxy, every atom might be linked to other realities, other versions of existence playing out in ways we can't fathom. The cosmic microwave background, the faint glow left over from the Big Bang, could it hold echoes of those other worlds, ripples from collisions we're only now detecting? Gravitational waves, those tremors in space-time, might they carry signals from across the brain divide? This discovery is a call to wonder, to awe, to the kind of curiosity that makes your chest ache. It's not just about equations or data, it's about us, about why we're here, what it means to be conscious in a universe that's revealing itself to be so much more than we thought. Some are even starting to ask, is consciousness itself tied to these boundaries? Could our ability to think, to feel, to dream, be a way for the universe to explore its own edges, to sense the other realities it's touching? It's a question that blends science and soul, one that might take centuries to answer, but oh, what a journey it'll be. As we stand on the brink of this new understanding, one thing is clear. The universe isn't just a place. It's a process, a dance, a conversation between dimensions, between realities. The simulation run on Azure didn't give us all the answers, but it gave us something better, a glimpse of the questions we need to ask. What's out there, beyond the edges of our cosmic map? Are we alone, or are we part of a multiverse, a tapestry of worlds woven together by forces we're only beginning to grasp? And if we're touching those other worlds, what does that mean for our future, for the fate of everything we know? This is more than a discovery. It's a wake-up call, a reminder that the universe is stranger, more beautiful, more alive than we ever dared to dream. It's a challenge to keep looking, to keep questioning, to keep reaching for the edges of what's possible. Because somewhere out there, beyond the stars, beyond the boundaries of space-time, there's a truth waiting for us. A truth that might just redefine what it means to exist. So let's keep chasing it, together with hearts full of wonder and minds open to the infinite. The universe is calling. Are you ready to answer? The universe is unraveling its deepest secrets, and what's spilling out is nothing short of electrifying. Imagine a cosmos so vast, so intricate that its edges don't just fade into darkness, they collide with something else, something alive with possibilities we're only now beginning to grasp. A groundbreaking simulation, powered by the raw might of Microsoft Azure's cloud empire, has peeled back the veil on what our universe might be expanding into. And the results are sending shivers through the scientific world. This isn't just about stars or galaxies, it's about rewriting reality itself, about discovering that our cosmic home might be brushing against a frontier so wild it could redefine existence. Get ready for a heart-pounding plunge into the unknown, because this revelation is packed with jaw-dropping twists that'll leave you questioning everything. Picture the universe as a runaway train, hurtling outward faster every second, galaxies flying apart like sparks from a fire. We've always thought it was speeding into a great big nothing, an endless void with no shape, no substance. But what if that's a lie we've told ourselves? What if the universe is smashing into a boundary, a cosmic shoreline where space-time ripples and bends under the weight of something other? The Azure simulation didn't just crunch numbers, it dove into the heart of this mystery using a digital tapestry woven from the latest cosmic data. We're talking observations from the James Webb Space Telescope, gravity wave whispers caught by LIGO, and quantum experiments probing the edges of reality. This was a beast of a model, designed to chase the universe's expansion to its furthest limits and beyond, to answer the question, what's out there, waiting for us? Here's where it gets mind-melting. As the simulation pushed outward, it hit something unexpected, a kind of cosmic drag like the universe was wading through molasses. This wasn't the smooth, empty vacuum we'd predicted. Virtual particles in the model started acting strange, their paths bending as if they were caught in a tug-of-war with an invisible force. The data screamed one thing. The universe isn't expanding freely, it's grinding against a barrier, a higher dimensional web that's leaving its mark on space-time itself. This wasn't random noise, it was a pattern, a signature of something with structure, maybe even intent. The numbers hinted at a trans-dimensional scaffold, a term buzzing in cosmology circles in 2025, suggesting our universe is threaded through a vast, unseen framework that shapes its growth. Feel your pulse quicken? That's the thrill of standing on the edge of a paradigm shift. The simulation revealed fluctuations in this drag, hotspots where the resistance spiked, others where it dipped like the universe was navigating a cosmic obstacle course. These weren't just quirks. They mapped onto predictions from cutting-edge theories about extra dimensions. Think of our reality as a shimmering film, stretched across a higher dimensional void. We live in 4 dimensions, 3 of space, 1 of time. But what if we're floating in a sea of 5, 6, or even 11 dimensions, curled up so tight we can't see them? The Azure data suggests those extra dimensions aren't just theoretical, they're active, interacting with our universe, sculpting its path through a reality far bigger than we've dared to imagine. Now let's crank up the intensity. The simulation didn't stop at detecting resistance. It caught something even stranger: echoes. These were subtle vibrations in the fabric of space-time, like the universe was strumming a cosmic guitar string. The patterns resembled interference waves, the kind you'd see if 2 realities were overlapping, their expansions clashing and sending ripples back and forth. This is where 2025's hottest cosmological buzzword comes in: brain resonance. The idea is that our universe is a brain, a membrane of reality, vibrating as it presses against another brain in a higher dimensional space. Those vibrations, they're not random. They carry information, maybe even hints of the physics that govern whatever lies beyond. It's like picking up a signal from another cosmos, a whisper from a neighbor we didn't know we had. This discovery is a gut punch to everything we thought we knew. For years, we've leaned on dark energy to explain why the universe is accelerating, a mysterious force we can't see or touch. But what if dark energy isn't the whole story? What if it's partly the pushback from this trans-dimensional scaffold, a cosmic tide we're swimming against? The Azure simulation showed that the universe's acceleration isn't uniform. It's lopsided, stronger in some directions than others. That asymmetry is a smoking gun, a clue that something outside our reality is pulling the strings. In early 2025, researchers analyzing the data proposed a radical idea. What we call dark energy might be the gravitational shadow of another universe, its influence bleeding across the dimensional divide, nudging our galaxies apart. Let's take a breath and let that sink in, because this is where the emotional weight hits hard. If our universe is tangled up with another, it's not just a physics problem, it's a story about connection. We've spent lifetimes feeling small, like specks in an infinite void. But what if we're part of something grander, a cosmic symphony, where universes hum together, their boundaries touching, their fates intertwined? The simulation's data suggests these interactions aren't static, they evolve. As our universe expands, it's not just growing, it's responding to whatever's out there, adapting to the push and pull of a multidimensional reality. It's almost poetic. The cosmos isn't a lonely wanderer, it's a partner in a dance we're only now learning the steps to, but hold on tight, because the plot thickens. Deep in the simulation, the team uncovered something that stopped them cold. A threshold where the universe's expansion seemed to stall. Not because of gravity or energy, but because the rules broke down. Beyond a certain point, the model's equations started spitting out infinities, paradoxes like reality was saying, "You can't go here." This wasn't a computing limit. Azure's servers were humming along just fine. It was a physical limit, a cosmic do not enter sign etched into the fabric of existence. In 2025, cosmologists are calling it the Planck horizon, a nod to the smallest scale of reality we can measure. The simulation then suggests that as the universe approaches this horizon, space-time itself starts to fray, its structure unraveling into something we can't yet describe. What's on the other side? That's the question burning up scientific forums right now. Some say it's a higher dimensional bulk, a chaotic sea where the laws of physics are rewritten. Others are whispering about a meta-reality, a realm where our universe is just one of countless experiments, each with its own rules. The simulation's data leans toward the latter, showing patterns that look eerily like computational artifacts, repetitive sequences, optimized shortcuts, the kind of thing you'd see in a system designed to conserve resources. In April 2025, a leaked paper from the Azure team sparked a firestorm by suggesting our universe might be hitting the edge of a rendering field, a boundary where reality simplifies, like a video game, cutting corners in areas players can't see. It's not proof we're in a simulation, but it's the closest we've ever come to evidence that reality might be coded. Your heart's probably pounding now, and it should be. This isn't just about abstract math. It's about what it means to be human in a universe that's revealing its secrets. If there's a boundary out there, what happens when we reach it? The simulation predicts that expansion doesn't stop. It slows, curving inward, like the universe is folding back on itself. Some theorists are calling it cosmic recursion, the idea that our reality might loop, restarting or merging with another as it hits this limit. Imagine the Big Bang, not as a one-time explosion, but as a spark in an endless cycle, each universe birthing the next, connected through these transdimensional frontiers. It's a vision that's both humbling and exhilarating, a reminder that our story might stretch far beyond the stars we see. And there's more. The simulation's latest runs, completed just weeks ago, picked up something that's turning heads. Anomalies in the cosmic microwave background, the faint glow left over from the universe's birth. These aren't random blips. They align with the resonance patterns from the model, suggesting that the early universe was already feeling the tug of whatever lies beyond. In 2025, new data from the Simons Observatory in Chile backs this up, showing tiny distortions in the CMB that could be scars from a dimensional collision billions of years ago. It's like finding fingerprints on the walls of reality, proof that our universe has been shaped by forces we're only now detecting. Every telescope, every detector is now hunting for these signals, racing to confirm what the Azure simulation is screaming at us. This discovery is a wildfire, spreading through every corner of science and beyond. It's not just physicists losing sleep. Philosophers, theologians, even artists are grappling with what it means. If our universe is part of a multi-dimensional tapestry, what's our place in it? Are we just passengers, or do we have a role to play in this cosmic dance? Some are even speculating that consciousness itself might be linked to these boundaries, that our ability to think, to wonder, could be a bridge between realities. In 2025, a controversial theory called quantum sentience is gaining traction, arguing that awareness might arise where universes touch, like static at the edge of a signal. It's a long shot, but it's the kind of idea that makes you lie awake at night, staring at the ceiling, feeling the weight of infinity. Let's zoom out for a moment, because this is bigger than any one discovery. The Azure simulation is a beacon, lighting up paths we didn't know existed. It's showing us that the universe isn't a closed book. It's a living story, written in the language of dimensions, vibrations, and boundaries. Every new run of the model brings fresh surprises, like finding a new chapter in a tale you thought you knew. Just last month, the team detected hints of dimensional drift, a phenomenon where our universe's expansion seems to wobble, as if it's being nudged by currents in the bulk. It's early days, but if confirmed, it could mean our reality is surfing waves of higher dimensional energy, carried along by forces we can't control. This is the kind of science that grabs you by the soul and doesn't let go. It's not about cold equations, it's about wonder, about standing at the edge of the known and daring to peek over. The universe is whispering to us, and for the first time, we're starting to hear it. It's telling us we're not alone, not in the way we thought. There's something out there, maybe countless somethings, waiting to be found. The stars above aren't just points of light. They're signposts to a reality so vast, so beautiful, it could break your heart. So let's keep listening, keep searching, keep dreaming. Because the universe isn't just expanding, it's inviting us to explore.